We classify our galaxies into four main types. We've got spirals, ellipticals, lenticulars, which is a mash between the two, and irregulars. However, there are so many other ways to classify galaxies, and today we're going to be talking about my top ones. Hello and welcome back to the channel, and an especially warm welcome to my new subscribers. We astronomers classify galaxies into four main types based on morphology, so your looks essentially. So to us, it were as if the universe were just one big beauty pageant and we were the judges. You might be disappointed by that, but unfortunately everything in space is rather far away from us, and so the best way of actually discovering space is just by merely looking. That being said, classification by looks gives scientists and astronomers a huge range of options when it comes to grouping galaxies, all depending on specific characteristics that we're looking at, and more on that anon. To commence, let's briefly establish the four main types of galaxies. If you want to learn a little bit more about them, specifically what the heck all those numbers and letters and brackets mean, then I've created an article quite a while ago which breaks down each of these little bits as simply as possible. Some of you might also be wondering why I'm dressed up as a Roman emperor, and the reason is I had just dyed 5 meters of this gorgeous cotton into this beautiful Tyrian purple colour, and it was just looking at me, and I thought I might as well take the opportunity to dress up a little bit. Who knows, I might come back as Marie Antoinette in the next video. The simplest galaxy is an elliptical, and this is basically an oval disk of stars. They're slightly rare, rarer than a spiral. They're usually quite yellowish, indicating that they're rather old galaxies. And of course, they have a supermassive black hole in their centre. These are subclassified depending on their orientation with respect to us, with bird's eye view ellipticals being marked 1 and edge-on ellipticals being graded at 7, because everything has to revolve around us, of course. Our most common galaxy is the spiral galaxy. These are a tad bit more common than ellipticals. They're usually quite blue because of their youth, essentially, and also within the middle of them they will have some hot dense gas and a supermassive black hole. Sometimes they will also have a bar in the middle, sometimes not. The main feature of these spiral galaxies is, of course, they're spiral, and they will be subclassified based on a number of different characteristics, such as the presence of the bar, how tightly defined or well defined the spiral arms are, and where the spirals actually terminate in the galaxy. They also get a luminosity classification, which classifies their, as you may have guessed, their spiral definition, not luminosity. Come on, guys. Many of these types that we're going to be talking about today have characteristics which are missed, mainly because of this kind of classification system. Lenticulars are a mash of elliptical and spiral. They could have maybe an elliptical shape, but a hot dense gas center in the form of what would be typical for a spiral, or something completely else. They're grouped depending on the presence of the bar, the definition of the bar, and also some dust absorption. Irregulars are anything that doesn't really match those. Surprisingly, there aren't that many irregulars compared to spirals that we see in the universe, which is quite interesting. I would have thought there'd be more irregulars than anything else, but that's probably just my linguistics brain talking. So now that we've covered the basic main types of galaxies, let's talk about some rather weird and wonderful types of galaxies. Flocculent is such a sweet word, and I wish we used it more often. Flocculent galaxies are, as the adjective describes, fluffy. These spirals have extremely undefined spiral arms, ones that are discontinuous in a way. This is due to how the stars form and propagate within the galaxy. Explosions or stellar wind may provoke the propagation of material and provoke star formation, which will spread across the galaxy. Messier 63, or the Black Eye or the Sunflower Galaxy, is actually my favourite flocculent galaxy, and it is a surprisingly dark galaxy due to simply dust. It may be difficult to see how these galaxies are spirals, but you can see in these pictures that there is some kind of spiral shape there. And when the universe is mainly filled with spirals, it's much more sensible to assume that these are spirals that are slightly out of shape, rather than a galaxy of an entirely different and complex structure in itself. Also, if I show you a flocculent galaxy in a different wavelength of light, you can see the spiral a lot more clear. Just under a third of all spiral galaxies are actually flocculent, so they're not as uncommon as people think. Next up are grand designs, and no, not the British TV show. These spirals are the big Beyblades of the universe, and they have well-defined arms which make up a large, or I guess you could say grand, portion of the galaxy. These arms wrap around the galaxy by a large degree as well. From the grand designs that I've seen, a lot of them have very few arms, 2 of them being very prominent and giving the galaxy its classical Beyblade shape. It's not very well known why these galaxies have their iconic shape, but the leading theory is that these arms are made inside density waves. These waves travel at different speeds to the individual stars that make up the density waves, and so what happens is winding, essentially. This is a very big oversimplification, but that lecture went over my head, I'm not gonna lie. Right, let's move on to elliptica. I'm just kidding, we're gonna stay right where we are with spirals and talk about Seyfert galaxies. Seyferts are part of a special kind of galaxy called an active galaxy, and in the middle of them they will have something called an active galactic nucleus. This means that the nucleus of the galaxy, so the supermassive black hole and the hot dense gas and material directly around it, make up a large portion of the galaxy's actual brightness. Now you might be thinking, well, isn't that just a quasar? Well, you're absolutely on the right track. Seyferts are almost as powerful as quasars. The main difference is that the active galactic nucleus of the quasar actually outpowers the entire galaxy itself, so the surroundings and the stars and the spiral arms or whatnot, it will outpower it tremendously, whereas with a Seyfert, it's slightly less bright than a quasar. Astronomers for a very long time, before we actually had extremely high-powered telescopes, thought that quasars were stars. Now Seyferts are simply just a step down from quasars. To see that in action, if I show you a picture of a Seyfert galaxy, you can clearly see that there is a galaxy, but that it's quite obvious that the nucleus itself is the powerhouse of this bad boy. Now let me show you a picture of the best quasar I can find. You can see it's just on a whole nother level. There are 2 types of Seyferts. Type 1 Seyferts have a lot of broad lines in their spectra. They also have a clear, large amount of hydrogen-1, helium-2 and oxygen-3 in their spectra. See, we're not being so superficial now. They also emit quite a lot of light in the X-ray. Type 2 don't really have these lines as much, and they have a lot of narrower spectral lines. We may also have a fair few forbidden lines, and this is where an electron within an atom may jump up or down to a rather unfavourable energy level, and this may be through something like a spin flip or some other kind of mechanism that's happening, and this happens at an extremely low rate. My favourite Seyfert is NGC 4151. This one is also called the Eye of Sauron. Starburst galaxies are bursting with stars, haha. No, really, it's true. These starburst galaxies have significantly higher star formation rates than your average galaxy. In a really loose way, they're kind of like the opposite of quasars. Because the actual disk of the galaxy is so bright due to all these new baby stars being formed, the nucleus kind of takes a back seat. And so, I mean, if we look at a couple starburst galaxies, can you actually tell me where the nucleus is for certain? I don't think so. Studies can be quite conflicting with the numbers, so I'll give you just a range, but the Milky Way will produce around 3 to 10 solar mass worth of star per year on average. These figures can change a lot, but a starburst galaxy can make around 100 minimum per year, which is a considerable amount larger. I mean, 10 solar masses in itself is quite a small amount. That could be around 15 red dwarfs, but this is the scale of the universe, and it's just something that humans can't really comprehend. Now, starburst galaxies aren't often naturally starburst. There's usually a trigger or an event which sort of triggers the star formation itself, such as brushing past another galaxy. It's these events that set off things like tidal tails and general instability, which will oftentimes ramp up the general activity of a galaxy and specifically its star formation. Starbursts have a fair few subgroups. You've got blue compact dwarfs, ultraluminous or hyperluminous galaxies, which emit a lot of infrared and are also very dusty. You've also got Wolf-Rayet galaxies, and these ones will contain a lot of Wolf-Rayet stars. These are ginormous, very hungry stars which just burn up all their fuel very quickly and just die, essentially, very, very speedy. And also one of my favourites, which is a delicacy among vegan cuisine, are the green peas. These are blue compact dwarfs, which just so happen to look like green peas, and I absolutely love that. What is really cool is, thanks to citizen science, there's actually more information about green pea galaxies than there are about flocculent galaxies, despite flocculents making up a huge portion of actual galaxies in the universe. And something really cool is that the green pea galaxies have a lot of forbidden lines, which gives them their really nice green colour. The most starburst galaxy that I know of is the Baby Boom galaxy, which, wow, is such a great pun, hahaha. This is a ginormous galaxy. It's really old and it'll churn out around 4,000 stars per year, which is incredibly ginormous. And it's just mad. And this galaxy is actually set to be one of the largest galaxies in the observable universe. Now we're coming up to one of the weirdest galaxies in my opinion. We touched upon ring galaxies in one of my previous videos when I talked about Hoag's objects. However, there is another kind of ring galaxy which sort of gets a little bit weirder, and I actually find it quite difficult to explain and comprehend just on my own, so please bear with me. When two galaxies interact with each other, we do know that there is a chance that they could form ring galaxies. But what's also interesting is that sometimes you can have hot gas which starts to orbit sort of around the pole of a galaxy. What might happen is one galaxy might strip away some gaseous material from the other, and this gaseous material might actually form a ring which sort of orbits around the galaxy, but as if it were like a planet with poles, essentially. And that produces something called polar ring galaxies. So a lot of these galaxies might have originally been lenticulars or ellipticals, but they clearly don't look like them after their collision. Another theory as to how these weird polar ring galaxies might have formed is an orthogonal collision. So very similar to how an actual ring galaxy might have collided, but you've got one galaxy sort of this way and one galaxy that way just colliding into each other, and one galaxy will actually take away some of that gaseous material to make that really interesting gas ring that's rotating around the galaxy. These galaxies I find are some of the most bizarre to look at because they clearly don't look like your average galaxy. But they look so beautiful and yet so odd at the same time. I absolutely love these. So when you compare them to spirals and ellipticals, lenticulars are actually quite rare. However, polar rings themselves only make up a couple percent of lenticular galaxies as well. So these are super, super rare kinds of galaxies, which is expected if they're caused by a collision. So that is but a small selection of all the weird and wonderful galaxies in our universe. If I covered every single interesting or weird galaxy, I think we'd be here all day, unfortunately. I hope I could teach you something unusual or interesting, and once again, thank you to everybody who's been subscribing to my channel and sort of interested in what I want to say, and I'm just so grateful for that, so thank you very much.